Welcome everybody. Thank you for joining my presentation about how Milan unlocks AVB TSN for especially audio applications. I've been involved in the specification work of Milan from the very first hour. Back then I was working with D&B Audio Technique, so we started that initiative in 2016. And what I found then is that it's still very complicated to implement this stuff. Although everything is specified and standardized, it's still a challenge for manufacturers to get this stuff implemented. And with that idea in mind, I founded JOYNED. So JOYNED is a provider of software solutions for manufacturers of audio equipment. But today we will talk more about what is actually Milan, how does it make things better for you in audio applications. First of all, what is AVB and what is Milan? So there is a set of specifications for what we call end stations. This is microphones, mixers, can be loudspeakers or other equipment in the signal chain. And Milan builds up on the AVB specification, which is basically an IEEE standard, which is still relevant for switches. So we need switches that support AVB. What that means in detail is something we will discover in the following presentation, but in principle, this is all you need to know to run an AVB Milan network. You need AVB switches, you want equipment that is Milan certified, and that allows you to bring audio from A to B, because that's what it's all about at the end of the day. We want to get audio from A to B in good quality, and we want to use the network for that. Who supports Milan? There is a big collection of manufacturers, very renowned brands, and also new brands who collaborate. Even strong competitors come together, collaborate on specifying Milan. Now, the third element, we talked about switches, we talked about end stations, we also need a controller to operate the network. So the third element you need to run a network is some sort of controller. And there is a variety of solutions available. There's Hive, which we consider more as a development tool. It's an open source project. So if you want to get a bit more into details, that's an interesting solution to look at. Then there's the Milan Manager. That's a solution that is neutrally branded, but was developed in a collaboration from L Acoustics and D&B. So that can be seen as the universal neutral tool that everyone can use, independent of the manufacturer, to operate a Milan network. And then a bit of different approach, a more visual approach to make connections is Nebra from Myosound. It is a solution solely developed by Myosound, but also works for every standardized Milan product. So we did a lot of market research and talked to users and tried to figure out what is the real pain point. And what we hear is, I don't want to be an IoT expert. It is still complicated to to configure switches with the existing solutions. Then important requirement is, once it's set up, I want it to be stable. I don't want to bother with, is there any dropouts, is there synchronization issues, stuff like that. And some even go as far saying it should be as simple as analog connections. The good old XLR is still what I want to have, but I also want the flexibility of a network. So it boils down to, we have an issue with switch configuration and management. We need a very reliable solution, and we clearly see a trend for open standards because there's an interoperability needed. We never see systems where everything comes from one brand. Usually there's a mixing desk from one brand, there's the microphone from another, and the loudspeaker is also from another. So we need these standardized interfaces between them. So in 2016, D&B, L Acoustics, Myosound, IAM, Avid was a small group of manufacturers back then, came together and we agreed on a couple of principles. So we say we want this enhanced IEEE standards. What exactly that means is something we will dive a bit deeper into. But back then AVB was known to be not really interoperable. You could follow the standard, a manufacturer could implement it, but it did not necessarily mean that you can connect to an AVB implementation from another manufacturer. So we need true interoperability, and that means we need a scheme for media clocking, we need common stream formats, We need all this definition to interface with control solutions, with the control software. And we also found there is a lot of ambiguities in this IEEE standards. And we wanted to add a redundancy scheme. So if something in the infrastructure fails, the other part of the infrastructure can still deliver audio without any interruption. So that was the baseline for all this Milan specification work. Now, you might have noticed already that there's a couple of consortia and many different names and buzzwords around, so I would also like to take the opportunity to clarify that a little bit. IEEE is the consortia that defines many basic things like Wi-Fi. The underlying technology is defined in IEEE standards. All our internet, all network we do, Ethernet, is defined in IEEE standards. So this is a very important consortia for a lot of technology that is commonly used. Then we have the Avenue Alliance. The Avenue Alliance is basically the body where these manufacturers come together, and it gives a legal framework to do this work. And from the Avenue Alliance, the Milan specification gets defined, and Milan is basically a trademark to give the whole thing a name. We didn't want just to have an IEEE standard with just another number. We wanted to be able to give it a name, and that's Milan. But it builds up on IEEE standards. Avenue is the consortia. So we end up working with IEEE standards and those Milan specifications, just to give that a bit context. So how does Milan compare to other existing solutions? I think what's important to understand is that everything builds up on IEEE standards. So it's not a black or white thing in that sense, but it's interesting to note that we keep developing these IEEE standards further. So Ethernet is a technology that was invented a bit more than 50 years ago, and it's still a relevant technology. So that's a very robust thing. But back then, it was not meant to be real-time. It was not meant to provide any means to do time synchronization. So it was just about data transfers. And nowadays, it's not only audio where this is relevant, it's also in automotive, it is also in industrial automation that we have these requirements, that we have high data rates, that we need to deliver reliably, and we need to add means for time synchronization. And that is what started with AVB. TSN is another buzzword in that context. It's basically just a renaming of this work group in the IEEE standards. And that adds all these deterministic synchronous features to Ethernet. And solutions like Dante, Ravenna, AES67QLAN, that's basically building up on legacy, what we call legacy Ethernet. So it's an older version of these IEEE standards, and that does not yet, maybe it will also in the future, but it does not yet leverage these new features of Ethernet to be deterministic. And that's what Milan fully leverages. Also interesting to know, as well as for manufacturers, but also for you as a user, is that there is a certification scheme. So if you see the Milan brand on a device, you can rely on the fact that the Avenue Consortium granted a certification for that, and that the device underwent some testing. So there is a well-defined set of tests that looks a bit complicated in that diagram. We don't need to go into details, but this is something we also help with as JOYNED to our customers to provide this as a service. The process for that is either the manufacturer or we as JOYNED generate test reports. It's an automated test that runs through. Then we have to go to an official test house that validates with a so-called quick test, and then the Avenue Alliance can grant this certificate. So if you see this Milan certification trademark on a device, you have full reliability that it fulfills everything that is specified.